So lesson 4, dimensional analysis. We've skipped lesson 3. We'll come back to it. Scientific notation. I did a really, really quick review of this the other day, but I want to do this properly because you need to reach the point where, Zach, you can do scientific notation almost in your sleep, where you can glance at a number and see it written in either scientific notation or in standard form in your head, showing no work. So, write the following in scientific notation. Okay. How would I write this? By the way, how many sig figs is example 1 there? 2. How would I write it in scientific notation? Okay, 3.1 times 10 to the 5. How many sig figs is example 2? 5. Yep. So I'm going to have to write 1.2044 times 10 to the what? 1, 2, 3, 4, 5, 6, 7, 8, 9, times 10 to the 10. I find for long numbers and small numbers, counting with my pencil still helps, because the classic mistake is you count wrong. You miss 1 digit. Example 3, how many sig figs is example 3? 4. How would I write? Now, first of all, I hate example 3 in that I would never choose to write it in scientific notation, because when you write it in scientific notation, it's longer to write it that way than in standard notation. But just to practice this kind of a number, I'll never expect you to do it on a test or a quiz, I don't think. What would I write? 3.162 times 10 to the times 10 to the 1. If I don't write anything, what's always there as an invisible exponent all the time? You can't make me write the 1. I'm not going to bother. Well, okay, it's scientific notation. I can see some of you guys cringing, saying, there's always supposed to be something. Fine. Example 4. How many sig figs? This is the tricky one. 3. 3. Why? Is there a decimal point? Zeros after a decimal, we have to assume were measured and are significant. So that's to 3 sig figs, which means I would write this as 1.00 times 10 to the 1, or times 10. And again, I have to be full honest, Vanessa, I would never write that in scientific notation. That takes 1, 2, 3, 4, 5, 6, 7, 8 characters instead of 4 characters. Stupid. Okay. Even example 5, a 4-digit decimal, I probably would just still write out. That's about my limit. 5 and 6-digit decimals, then scientific notation becomes, I think, kind of handy. How would I write example 5? 4.5 times 10 to the -3, -2, or -4? Okay, it's -3, because you start with a decimal and you're moving it between the 4 and the 5. And if you're not sure, count with your pencil or pen. Then all you have to remember is that the negative exponent means you're dividing, and that's why it's a decimal. Oh, by the way, how many sig figs is example 5? 2. Zeros in front, we don't care about. They're placeholders. 6. How many sig figs? 3. It's going to be 7.06 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. -9, is that what we got? Yep. What is 10 to the -9 on your yellow formula sheet? Is that nano? Yeah, okay. So 7.06 nanometers, liters, whatever, but there you go. How many sig figs in example 7? Not 1, 3. So that means I'm going to have to write 6 point, I have to assume they meant those zeros after the 6 to be there, otherwise they wouldn't have put them there. Times 10 to the -7. Is that right? 7, is that right? Looks right. Because we don't use commas in between groups of 3 zeros for decimals, it's a little tougher to count with decimals. With bigger numbers, because of the commas, I just count up by 3s and then add whatever's left over. A little easier. You good, Dro? You awake? Okay. 8 is another example. There's no way I would write this in scientific notation. First of all, how many sig figs? 3. If I wrote this in scientific notation, it would be 6.30 times 10 to the... Yeah, because 10 to the 0 is 1. What a stupid way to write it, but okay, I showed you that it can be done. But why would you? Going backwards, it says write the following in standard form. By the way, here is why I said sig figs works so nice for scientific notation. Jake, if you look at the number of sig figs, 3 sig figs, 2 sig figs, 1 sig fig, 3 sig figs, 2 sig figs, 1 sig fig, it really stands out. Scientific notation, hey, whatever's showing up there, the front of, there's probably a fancy name for the number in front of the 10 to that, and I've never looked it up. I really should because I'm a nerd. But whatever that number is in front, however many digits there are, that's the sig fig. So it's much easier in scientific notation to do sig fig questions. But, okay. Write the following in standard form. So I'm going to write a 2, a 3, a 4, and how many more zeros? 7? Why? Oh yeah, 5, because the 3 and the 4 took care of 2 of those places. 1, 2, 3, 4, 5, comma, 23,400,000. That one there, I probably never would bother writing in standard form, but example 2, that's a handy one. When I see a 10 to the third, I've reached the point when what is 1.5 times 10 to the third if I write it out? Yeah, I see that it's 1,500 because that's easier to type, quicker to type, and we did the penny video the other day. I can visualize 1,500 fairly easily. I know about how big that is. Example 3. Example 3. What? 3? Example 3? 3? Example? Yeah, I said example 3. Oh, you mean that's the... yeah, 3. I lost him. Where is it?
I understood the joke.
Yeah. Have I done my Doppler effect comment in this class yet?
Who's Doppler?
Yeah.
Oh, okay. Doppler was a scientist. The Doppler effect, how many of you have ever been to the Abbotsford Air Show? Okay. When the jet fighters go by, they go by so fast, you see the jets, and then you hear the jets. The sound is actually traveling slightly behind them. Did you notice? It's really quite cool. We call it the Doppler effect. I have a feeling in this class, I'm going to tell a joke, the class will laugh, and then someone else will get the joke and laugh as well. I don't know who it's going to happen, but there's going to be a Doppler effect.
I wasn't off point, like I laughed when I should have.
Yeah, we believe you. Anything you say, I believe.
Maybe I was fake laughing, because it wasn't funny.
What am I going to write here? How many zeros am I going to write before I start writing the 167? Yeah, 4. It's a -5, but the first digit takes care of 1. It's always 1 less 0 than the negative number. So 1, 2, 3, 4, 1, 6, 7. And again, that's a number that's a small enough decimal that I probably would just leave it in scientific notation. Certainly something like example 5, I would say to myself, I would prefer not to write that in standard form, but since that's what we're practicing, it's going to be 0. The exponent is a -8. Brandon, that means 7 zeros. 1, 2, 3, 4, 5, 6, 7, 1, 3. Example 6, 3 times 10 to the 8th. How many zeros? Yeah, 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. 300 million? 300 million. So, Justice, your goal is to be able to flip-flop back and forth fairly effortlessly. And you know what? Kind of make sure you can do it for the quiz, but we'll be using it so much this year that by about Christmas, it'll be effortless. And especially if any of you are also doing chemistry at the same time, it'll become like a second language. We're also going to be doing arithmetic calculations with scientific notation. So this is especially important. Those of you that didn't have your calculator last day, this is our chance, our one last time, to figure out how to use our calculators for scientific notation. Get them out, please. And can you calculate example 1? Not yet?
No.
Got to get one. Otherwise, I'll start having to treat you like a kid and give you detentions and all that crap. Don't make me, please. So my Doppler effect really should have been everyone gets a calculator. And then maybe, okay. How many numbers are there on the top of this fraction? How many different terms are there? Probably should put it in brackets, although how many things are you dividing by this time? How many terms? Because you're only dividing by 1, you can be sloppy on the top with brackets, but it's a good habit. You have more than one term on the top, surround it with a bracket. Always, if you have more than one term on the bottom, surround it with a bracket and use your scientific notation button, and I'll show you why on the next example. For now, I would type this. Open bracket, 1.34. I'm not going to hit times. I'm not going to hit 10. I'm not going to hit to the power of. I'm going to go scientific notation button, which contains all of that, 7. And I said last day, when I have a bracket, I replace that with a times sign. 2.2, try that again, Mr. Dueck, 2.2, scientific notation button, -4, divided by, since there's only one number on the bottom, 1.8, scientific notation button, 12. And because I used my scientific notation button, Cole, my calculator knows I'm dividing by that whole thing. If you had typed times 10 to the 12th, your calculator would only divide by the 1.8. It wouldn't know that you also wanted to divide by the 10 to the 12th. And that's why I went on that rant the other day. I said you should, when you're using scientific notation, use that scientific notation button. It tells your calculator that's all one number attached together. You should get 1.6377 blah blah times 10 to -9. Is that right?
Yeah.
How many sig figs? How many sig figs? No. How many sig figs am I rounding my answer off to? 2, right? 2 of my digits. We're multiplying, which is the easier rule. 2 of my numbers have 2 sig figs. So it's going to be 1.6 or 1.7? 1.6 times 10 to the -9. So here's going to be my rule for the remainder of the year for sig figs. On quizzes and tests, I won't take marks off if you botch sig figs, but whenever I'm doing questions with you, you'll almost always hear me say, oh, by the way, how many sig figs? Once in a while, I'll say, we're going to ignore sig figs, but it's just a good way to review. Example 2. More than one thing on the top, bracket. 6.67 times 10 to the -11 times 5.98, scientific notation to the 24th, times 1200. By the way, this is the equation for the force of gravity between the Earth and a 1,200 kilogram object sitting on its surface. You'll learn that in about 2 months. Divided by, I wonder, I'm going to go 6.38 scientific notation button 8 squared. I wonder if I have to put that in brackets so that it knows to square. Actually, I think if you use your scientific notation button, I think your calculator, if you put a squared after scientific notation, knows to square the whole thing. And this is again why I went on that rant. Use your scientific notation button. In fact, I know it does. If you did not, if you still like to go times and 10 to the power of, you'd have to put that whole thing in brackets with the squared outside the same way that I typed it. But I'm pretty sure Is that right? 1.157, that? Yep. Okay. Yeah.
I don't know if my scientific notation.
Oh, you didn't have it here yesterday?
No, I didn't.
Good, thank you for asking, but next time ask sooner. Right there, X. Right above the 7. It's a cheap POS, by the way. If you got $20, get something better. You can get through it fine this year, but, or if you find, if you got a sibling who's graduated who has one kicking around or whatever, it's nice to get one that has arrow keys and a 2-line display. And I don't think that has arrow keys. Does it have arrow keys?
I don't know if it's
Oh.
They're arrow keys, but they're buttons. Like they all do different things.
Oh, okay. Hey, how many sig figs in this answer? Let's see. The first thing is 3 sig figs. The second thing is 3 sigs. Ooh, that 1,200. How many sig figs? So 2 sig figs. I'm going to go 1.2. Okay. Turn the page. So we'll go right to the tone. I know it's lots of me talking, but no homework for the weekend, so I think that's a laudable goal. Right? Who's in chem? Who has a quiz on unit conversion today or something like that? Okay, here we go. So, using metric prefixes, convert the following. 12 megagrams is how many grams? The short way, by the way, if it's a simple one-step, one-way conversion, is to realize that if I'm going from mega to grams, this is going to be 12 times, what's mega replaced with? 10 to the what? It's that many grams. I can replace a 12. Now, that's not scientific notation. That's sloppy, because scientific notation would be 1.2. So really what I would do is I would go to my calculator and I would say 12 times 10 to the 6th power. This is not scientific notation, so I'm not using my EE button. But when I hit enter, it would say that, or 12 times 10 to the 6th. Sorry, equals 1.2 times 10 to the 7th. If you give me 13.6 milliamps and you want me to go straight to amps, the really, really quick and fast way is to realize I can replace milli with a power of 10. What is the power of 10 that I can replace milli with on my formula sheet? Negative, okay. So this is 13.6 times 10 to the negative 3 amps. I would not leave my final answer. I would now actually go to my calculator and I would say, okay, 13.6 times 10 to the power of negative 3. Mr. Dueck, how come you're not using your scientific notation button here? Because I'm not doing scientific notation. This isn't one-term expression. I'm actually crunching a number. It just happens to be a 10. And I get 0.0136. What we want to talk about are two-step conversions. And by two-step, I mean when you're going from one prefix to a different prefix, you're not just stopping at the base unit. And you may have your own method for doing this, and there are shortcuts, but as I was saying to one of my students this morning, I'm the kind of person, unless the shortcut really saves me a lot of time, if I find a one-size-fits-all works for anything, I'm going to use it. So here's my one-size-fits-all works for anything. Example 3. They want me to change 13.6 kilograms into micrograms. You know what the first thing I'm going to do here is? I'm going to write down what they gave me, and I'm going to do it off to the right where I have some room to show work. So I'm going to go like this. 13.6 kilograms. Yay, Grant, I feel better. I wrote something down. I'm going to multiply by a conversion factor. Now, my strategy is going to be this. I'm going to go from kilograms to grams, because I can do that, and then from grams to micrograms. It's going to be a two-step chain. So kilograms is on top. Alex, I'm going to put it on the bottom. I'm going to put grams right there. But what can I replace kilo with? What's it the same as? 10 to the? And that would cancel out the kilograms, and that would get me into grams. I don't want to stop there. Jake, I'm going to multiply again. I want to get rid of the grams. Right now, in my middle term, the grams are on the top. So where are they going to be in my next conversion factor? and I want to end up with milligrams. Oh, on the top I have milligrams. This is not correct yet. On the bottom, in front of the grams symbol, what's milli the same as? 10 to the what? Micro, I said milli. Micro. But it's 10 to negative 6, yes? Do you see how I was able to figure out, first of all, where the powers of 10 go? Okay? Thumbs up, Taylor? Yeah? And can you see what I'm going to go? Oh, by the way, Taylor, for what it's worth, there's an invisible 1 there, an invisible 1 there. I'm going to ignore those. I think it's going to be, Taylor, 13.6 times 10 to the third divided by 10 to the negative 6 on my calculator. That's going to be it. So here we go. 13.6 times 10 to the third divided by 10 to the negative 6. Apparently 13.6 kilograms is 1.36 times 10 to the 10th micrograms. My calculator gave it to me in scientific notation. I don't know if yours did, but since it gave it to me in scientific notation, I'm good with that. .36 times 10 to the 10th micrograms. Next one, going from nanoliters. Is that okay, Mark or Olivia? Yeah? Next one, going from nanoliters to megaliters. Okay, it's a two-step conversion because I'm going from one prefix to a different prefix. No problem. I'm going to go from nano to liters and from liters to mega. First thing I'm going to do is write down what they gave me. By the way, the abbreviation for liters, you can either use a capital L or use a handwritten L, but don't use a lowercase l like that, because what does that look like? A 1.
Like an I.
I'm going to multiply by a conversion factor. What do I want to cancel out? Put it on the bottom. What's nano the same as? 10 to the? So I'm going to say on the top, that's the same as 10 to the negative 9 liters. And that would get rid of nanos. Now I'm in liters, but I don't want to stop there. This question says finish in mega. So, okay. Where do I want to put the liters in the next fraction? On the top or on the bottom? On the bottom this time. I want the mega liters to be on top. But this isn't correct. What's mega the same as in front of a liter symbol? Can you see it? I think it's going to be 2,000 times 10 to the negative 9 divided by 10 to the 6th. Yeah? And I get 2 times 10 to the negative 12. And I should probably go to 1 sig fig because that's the data that they originally gave me. Is that okay? Try 5 on your own. Okay. I'm going to freeze the screen.
I actually like it. How's your thing?
It's funny, I started doing this about 8 years ago, and I noticed as soon as I start playing it, everyone's pencil starts to move faster and you tense up. You're conditioned to work faster because you've heard this all your life. I don't know why, but it's like, must work faster! Anyways.
I was enjoying it.
Yeah, that's a good one.
Let's see here. That goes meters times, I want meters to cancel, I want millis, and that's 10 to the negative 3. I'm getting an answer. Oh, I'm going to write this in scientific notation, I think. You get 3.425 times 10 to the 8th. You get 3425 and 5 zeros after that, which I would write in scientific notation. Okay? So when I see you again on Wednesday, we're going to pick up with multi-step, so more than two-step. And we're going to say, you know what? It's not going to be a new skill. It's just going to be longer chains. So your homework right now, you have none. I have a little, it's not exactly a video, it's more of a recording. Give me a second here.